Ah, yes. Happy Sunday to begin with. It's a pleasure to welcome you all. We have a new chapter for Tamil Nadu as our Vijay is taking as a CM post, and we also have a new chapter for psychiatry, that is AI. The more I think about it, the more I feel today's topic and mood of our state have so many things in common. Our state is beginning a new journey. Mental health care too is beginning a new journey. AI, if you see the both the things, both are hope, both are about blending the old and the new. And there's some questions stands before both the new government and artificial intelligence. Is it friendly? Is it stranger? Or it's something in between? That's why this conversation couldn't come at a better time. So our three speakers here to help us explore that. So first speaker is Dr. Srinivas and Rajkumar. So, Sir is going to talk on introduction to AI in psychiatry. Is MD in psychiatry from All India Institute of Medical Science, New Delhi. Completed his DNB, MBA from BITS Bilani. Consultant psychiatry in Apollo Healthcare, Velachery, Chennai. Is also an assistant professor in Sree Balaji Medical College, Chromepet. His work focused on integrating a clinical practice, neuroscience, digital mental health care, and neurotechnology into a routine mental health care. He is experienced in advanced treatment assessment modalities, including RTMS, ketamine therapy, EEG-based assessment, neurofeedback, computerized cognitive testing, AI-assisted psychiatric evaluation. Dr. Srinivas has been actively involved in mental health education, community outreach, teaching, public awareness, working with NGO schools, college, technology companies, media platform, community organization. To improve mental health and access to care, he has several publications, presentation, and award to his credit. To address the underdiagnosis of dementia and other mental health condition, he helped establishing the Mind and Memory Clinic with Mind and Memory Lab, focusing on structured assessment, cognitive evaluations, and technology-assisted psychiatric care. He also co-developed the MindCare AI, an artificial intelligence enabled tool designed to aid in assessment of mental health condition. We are honored to welcome you, sir. And our second speaker is Dr. Iniyan. He is going to talk on the topic deep dive into AI technology. He is an academician, clinician, researcher with 10 years experience in field of psychiatry. His current designation is a professor and head of the department in Saveetha Medical College, Chennai. He completed MBBS from Kanyakumari Medical College and MD Psychiatry from Stanley Medical College. Expert at technology-based innovation, teaching, learning, and methodology and research methodology. His area of interest include integrations of artificial intelligence in healthcare and UG and under UG and PG academic training. He made presentation various academic and public forums. He has more than 25 publications, including 8 in Scopus Index Journal. He completed a course of leading for innovation in healthcare from Warwick Business School, England. Has completed a course in innovation in healthcare at Harvard X on online learning initiative of Harvard University. Has completed an online course on prompt engineering for educator by Vanderbilt University, United States. Has built a multiple applications for mental health, academic, and research. Welcome you, sir. And our third speaker is Dr. Vikas Prabhu. So topic is on speaking the language of mission, prompt engineering. Is MD and MRCP psychiatry with experience in clinical psychiatry across the outpatients and inpatient setting. His academic interests include psychopharmacology, psychotherapy, neuropsychiatry, and role of psychiatry in mental health. He also the author of books exploring the psychiatry, mental health, and human behavior, including Beyond the Code, the Soul Research Guide. He is the founder of Vivid Mind Project, an initiative focused on mental health awareness, psychological education, and making a psychiatric knowledge more accessible to the public. So if you see all our eminent speaker, it is not about a clinician, it is not about research, it is not about academic. They also have a very additional value of innovations of technology in mental health care. We are honored to welcome you, sir. Yes, we can start, sir.
Yeah. Thank you, sir, for the warm introduction, and thank you,
Thank you.
Sadanan, sir, for this opportunity. And also, thank you, TNIPS, for providing this stage and to discuss an important topic. So, without further ado, I think we'll start with the presentation. So, participants, you can please share your queries and other things in comments so that we'll keep the conversation alive during the later part of the presentation. So, as an introduction to A in psychiatry, we'll discuss under several headings. That is, first we'll start with the development of A as a separate discipline and how. Then we'll bring it to the relevant aspects of A which we can utilize in psychiatry. Then about the possible implications, whether A is going to replace a psychiatrist or is it going to assist us and fill the treatment gap, the possibilities and innovations, and then we'll discuss about the perils, pitfalls, and then we'll have an open discussion. So you all might be knowing these two people, right? In 2004, Hopfield and Hinton got the Nobel Prize in Physics for developing the earlier tools and architectures which enabled the current AI. So what did they both do? Right. So when we discuss about Hopefield and Hinton, we forget the role of an important psychologist who contributed to ideas which would later be incorporated into the works of Hopefield and Hinton and made current AA possible. So that is Donald Hebb. So see, the initial discovery, even now we take it for granted that when a memory is formed, there is a synapse being established. But this discovery, imagine in the 60s and 80s, how difficult this discovery would have been. And that was made by Donald Hebb. So he hypothesized and proved in experimental condition that learning occurs because of connections between the neurons. And this reinforcement occurs when they continue to work together. And the same concept of building a artificial neural network which can mimic the functioning of the brain was also put forward by Donald Hebb. So the same parallels, that is, neurons are compared to nodes in, say, AI systems, and the synapses are represented as connections or communications between the nodes. So this we'll be discussing in slightly more detail. So as we see on the left, you can see the normal synapse, that is two neurons interacting with each other. And if you look at the artificial neural network, they also follow a similar structure, right? There are nodes. Then the values are provided to represent the connections and how they have to be active or inactive at a moment. That is 1 representing the active state and 0 representing inactive state. And also weightages are given to the connections between nodes, that is representing a stronger connection and weaker connection. So almost parallel to how our normal connections in our brain would work. And this is very important. So beyond this conventional architecture of neurons, they also created layers of how our brain or our neural network would interact with external information. So the initial model was the Hopfield network, a slight expansion of the synapses. Then they created Boltzmann machine. So here what they did was there are both visible and invisible layers. That is, when a layer is being trained or when the information is provided, it would be in the visible layers. But with successive layers of training, there would be larger or multiple layers of deeper hidden networks, which when required can interact. A slight advancement of this is the restricted Boltzmann machine. So even though these terms appear foreign, the Netflix algorithm, which we interact on an everyday basis, works based on restricted Boltzmann machine, the concept under that. That is, when you watch a for example, a movie or a series, then restricted Boltzmann algorithm is capable of predicting what this user will want to watch next based on like information gathered from your own usage patterns. And also there is another term called pre-training. You can program it to provide certain kind of feedback. So our modern AI is just an exaggerated or stacked version of restricted Boltzmann machine. Though now, because of the layers of complexity we are able to add, we can tune in multiple parameters that is beyond the, say, a single unidimensional layer of Hope field network, or a multi-layered three-dimensional Boltzmann machine, or a stacked restricted Boltzmann machine with multiple layers. We are able to incorporate more sophisticated algorithms into it. So simply explaining, for example, so this is an easier analogy to explain rather than going to core physical concepts. For example, when a patient sits in front of you and you want to make a diagnosis, what do we actually do? So we start from the unknown. That is, you start from the patient's name, age, you start to get details. What is in your mind is a clinical diagnosis. Say here the example is a dot form of J, that is there are multiple dots, that is the patient is providing multiple information which you try to fit into the diagnostic construct you have in your mind, right? So A also works in the same fashion. For example, if you look at this input pattern, what can you infer from this? So initially you see, okay, there are multiple dots. Over time, your brain organizes it into a J because it matches with what exists inside. That is the previous learned experience or learned knowledge of the existence of this letter. So when a stimulus is provided, it navigates, from a higher energy, that is a distress state. When you process this, you feel a sense of distress, something uncomfortable. This is something I know, but I have not figured it out. So once it reaches the energy minima or when the balance is achieved, then the brain figures out that, okay, this is J. This is how normal algorithms work. For example, when image recognition, if you take a photograph and ask, what is this? It tries to match with what exists inside. The same way with the information provided to the AI tools. They try to match it with the existing algorithm. Once they feel the energy minima is achieved, they represent that, okay, this is the inference. And because this structure, even when you see, this is prone to inaccuracies because the way how you write a J or like how the pre-trained model, like, there are several ways to write a J. It could be small letter, it would be capital letter, there could be some cursive writing. So based on that, there may be inaccuracies, and also leads to, because of the nature of the alphabets, because they have like, they don't have, fixed, like for example, J can be written in multiple ways. You can even put a line here, then you can put it like this and write a cursive letter. So because of the difficulty in training to match this information, there can be inaccuracies in how a model interprets the data provided. So as an extension to the previous Boltzmann equation, the current AI models are multiple layers stacked. In the initial, when the initial models were developed, they had the restriction of, limited computing power. But, we have like AI data centers, we have like, huge models with greater parameters. So we are able to process multiple layers of information. That is, there is an input layer, then there are multiple stacked hidden layers, and there are interconnections between the layers, which helps us to, process the information, store the information, and interpret new information in the light of the previously stored data. So with every query, there is a tightrope of, balancing the information provided, matching to the existing algorithm, and providing an output. So AI in psychiatry. So how do you make use of this AI systems in psychiatry? See, currently the easiest integration possible was to replace, previously you would have known something called your dost. There was like forums and chatbots, which actual humans manned. But over time, now we can see that they are manned. Initially, they were manned by bots which provided generic responses, but now they have been replaced by slightly intelligent bots which can actually read the information and provide slightly customized responses. Some of the popular options are Wobot, Visa, and Replica. But beyond this, FDA has approved certain interventions. For example, therapy is very time intensive, resource intensive, and even in our own practice, we would see that people would be waiting for a long time before getting an appointment. Then again, the individual variation in therapy, like a lot of people try to use so-called eclectic therapy. They used to mix and match interventions. Some people are trauma focused. That leads to like unstandardized therapy. So there is a constant push on, for example, manualized therapies which are structured to be converted into applications and AI platforms. So some of these have like early approval, or they are under some pilot programs. They are used by organizations like NHS and FDA. So rejoin, then there is so rejoin is just to deliver CBT based exercises, but they have also moved to the next level, that is clinical outcome assessment. So this is an AI driven tool which can assess anxiety and depression symptoms independent of human intervention. Then there is CT 155 by Ingelim and Click Therapeutics. So they are digital therapeutics. So both in CBT, clinical outcome, and also for therapeutic interventions, AI has proper approvals, or at least yearly approvals. Here we'll go to the main problem with incorporating something like AI in psychiatry, right? For example, AI is very good with simpler tasks. For example, if you ask for mathematical calculations, even though there are a lot of videos showing it is inaccurate in certain aspects, but for direct questions, it is very good to respond. The problem of incorporating AI in psychiatry comes from the way psychiatry itself is structured. So as a continuation to my previous presentation of objectivity in psychiatry, the very problem that the way we define psychiatric illnesses makes it difficult not only for machines, even for humans to classify illnesses. We often see in our clinical practice that there is a constant overlap between diagnostic entities, and we also see that over a course of time, the diagnosis keeps changing, right? So in such a state, it is very difficult for us in the current existing paradigm to teach the machine how to make a diagnosis. So to make AI incorporate psychiatry in a useful, meaningful way, there is a requirement to restructure the way in which we approach diagnosis. So as in the push for DSM-6 and also as mentioned in the RDoc, there is a need to operationalize psychiatry in the way other medical disciplines have evolved. For example, early in the day or even during our clinical days, there was huge emphasis on palpating a tumor, defining it, defining the texture, vascularity. But now, what do? We start with ultrasound, we look for tumor markers, and then we make a very precise diagnosis. The same way in psychiatry, we have to move beyond symptom clusters and try to make more sophisticated diagnosis focusing on brain circuits, genetics, and cognitive processes. Hence the push for dimensional, although incomplete push in ICD-11. So we have to incorporate a more sophisticated system which is more accurate and more easy for humans and machines also to communicate. So this is the real problem with psychiatry itself. Like there are three entities. There are true diseases, circles, and types. And our psychiatric illnesses fall either as circles or as types, but never as true diseases with clear demarcation with other illnesses or other psychiatric conditions. So with these fuzzy boundaries, right, we cannot meaningfully incorporate current psychiatric diagnosis with reasonable accuracy for our clinical practice. So this is an explanation of RDoc, how we can incorporate multiple layer. The thing is, it is not only that enabling AI or incorporating RDoc or a more sophisticated, biological approach into the newer diagnostic system will make AI possible. When such systems are incorporated, it may be actually difficult for mere human effort to interpret all these variables. For example, currently we make a diagnosis of depression, mild, moderate, severe. Okay, 3 major symptoms are there, 2 minor symptoms are there. Then we attribute the severity rating. But when we move to such sophisticated systems, it may be impossible for human beings to make a diagnosis in OPD without the aid of AI or other tools. So as I said, the current diagnostic systems have like great diagnostic systems don't delineate illnesses separately. There is a huge overlap between illnesses, which makes it too difficult to teach the machine how to interpret the symptoms. So what will AI do? Will AI replace a physician or will it be serve as an assistant? So we all know, like based on the National Mental Health Survey done by NIMANS, and the second survey is also like ongoing. We know that 70 to 90% of people with mental illness and substance use disorder don't seek treatment. So AI can bridge the gap between this stigma attached to treatment seeking. So there is an initial layer for which we can use AI to do preliminary assessments. And then with the rise of, for example, when we use a fitness tracker or an Apple Watch, it can even predict that, okay, this person is going to have a syncopal attack based on the, variation in the heart rate. Then based on, constant like increase in heart rate, it can predict, okay, this patient may have underlying cardiac disease. So with the advances of like continuous wearables, tracking, for example, tracking the sleep data, we can also predict whether a patient with illness or without illness has a predisposition or is he going to have a recurrence of the next episode. For example, the earlier studies in bipolar disorder show that, okay, there is a constant decline in energy level before the onset of next depressive episode. Then with the onset of mania, there is decreased need for sleep, increased activity. So basic behavioral parameters can be used in addition to conventional tools to detect early occurrence of symptoms. And because when we increase the number of variables we are tracking, it will be difficult for mere human intervention to make a sophisticated recommendation, right? When we use our conventional systems, we will be only able to make conventional recommendations. So when we increase the number of variables we have to incorporate, so as to call, for example, in human intervention, like, right, we border around 50 to 60 diagnostic accuracy. But when we move to AI, diagnostic accuracy can increase to 85 to 90%. Then some of the proven tools which were tested analyzing the electronic health records, they can even detect suicide risk with 70 to 85% sensitivity based on, say, social media, like sharing patterns, wearable data, and also the health records. Then again, the most important change comes from studies on documentation in Western countries. For example, NHS, death by writing a case sheet, particularly for psychiatrists. But they have seen that even incorporation of like minimal AI assistance systems, it is not like replacement systems. So this NHS study was done over some 400,000 hours. It showed that NHS staff using simple co-pilot along with their regular clinical data entry screen can save 43 minutes per day. So that is a huge saving. So current system of clinical practice, without using AI or without having machine in the loop, so as to say, is inaccurate. There are inherent biases. There is variability. It is time and labor consuming. It is expensive, and there is stigma, particularly in mental health. There is inconsistent monitoring, and it is less precise. But once we incorporate AI, we'll be able to incorporate more sophisticated sources of data beyond pure symptomatic or syndromal diagnosis, incorporate multiple parameters, behavioral data, EEG, fMRI, polysomnography, genetic studies, lab data. Then we can profile them in a more sophisticated way beyond the conventional diagnostic systems, have more precision measures to estimate prognosis and also monitor progress. So both before diagnosis, in the diagnosis, and also in follow-up for passive data collection, continuous monitoring, alerting, we can use AI-assisted systems. See, though, so is it possible, as I said, if you ask the current generation of proponents who are working in both AI and healthcare, they look for radical change in healthcare system to be able to incorporate AI. In the current form, building a healthcare app or following all the compliance requirement becomes very difficult because the way the current healthcare system is structured. So currently the initial work is only based on what you say, like some assistant systems for note taking. Then some post monitoring is like outsourced to the, like say, wearable, some from the family member as we do in psychiatry, and some to the wearable. So once we have a very good integration of, say, healthcare systems, the electronic health records and behavioral data, we will be able to track a lot of things. For example, to the extent of one may call huge invasion into the privacy. That is person smartphone usage, social media activity, then wearable device information, then based on like geolocation and all those information is collected. Then there is a compiled so-called digital phenotype of the individual, and then from that we can feed the information to our trained AI systems, which reduces, like for example in Western countries, at least we have, in addition, India's problem is treatment gap, their problem is waiting period. So all those issues can be addressed once there is a good incorporation of artificial intelligence driven tools. So with such incorporation, like for example, beyond the conventional diagnosis, because we have very individual profiling of patients, like very personalized profile of patients, we'll be able to use these data to create more curated recommendations rather than, generic systems which exist currently, because we have only converted manualized interventions to app-based or AI-assisted systems, that is CBT, or you teach JPMR, or you teach some, relaxation breathing techniques. Those things can be easily converted to an app or say like an AI assisted system. But to have more personalized, we have a long distance to go. So even though there is a strong push for AI, it is not without problems. Okay. So we would have read about the news of a death of the Belgian man. It's like the movie Her, right? A person was involved in prolonged chat with a chatbot. But when the chatbot encouraged him to end his life or sever the connections, he apparently ended his life. Then there is one more case of a Florida teenager who also, ended his life by suicide. So these are not only isolated cases. For example, if you see the literature, the very method or like the very mode of communication between AI chatbot and a human reinforces certain symptoms. So they have developed a trans-diagnostic model of how chatbots can worsen symptoms. So the studies are mostly done on OCD, anxiety, personality disorders, and psychosis. Because the AI apps not only are designed to provide you information or assist, they need user engagement, right? They want you to continuously communicate with it. So some of the sentences or some of the ways in which it communicates with you is also to hold you in the app. So when AI provides, feedback which is contrary to your belief structure or directly challenges your symptoms or belief systems, people are likely to drop out. So in OCD and anxiety, it perpetuates maladaptive cycles and it hinders corrective learning. So some of the studies done on this, they have provided alternative, like for example, ways in which chatbots can communication and prevent such interactions. So they have made a framework of how we can avoid these type of interactions. So strategies what clinicians can use, what users can use, how developers and policymakers have to take into account while designing such systems. So again, this is one more case of feedback loop between AI and chatbots. So it is like kind of a shared delusion. Like when the patient interacts with a tool, it tends to promote patient's belief, and like over time, when you interact with it, it may start to share the same thing. So it's like a shared delusion. So as such, in the current system, the way psychiatry is structured, that is like this clinical interview, excess focus on phenomenology, which even our current diagnostic systems are trying to move away. Previously, we need to have a specific form of delusion, a specific form of say somatic experience to call it as, the major symptoms under schizophrenia. But now we have moved to simpler forms of like delusion, hallucination, some somatic symptoms, then limitation of functioning. So as there is a constant movement from, excess emphasis on phenomenology to, more universal ways of describing symptoms, and then the migration to RDoc or more neurobiologically oriented diagnosis, it will become easier for us to teach the AI and also use it as an assistant along with this. So currently, AI should do a lot of things to be able to assist us in the current form. It should support pattern recognition. It should promote like structured reporting. It should know phenomenology very well to ask the enough details. Then again, differential diagnosis, because we ourselves don't have clear boundaries between diagnostic entities. How will AI make this clear distinction? And again, decision support is only bound to be inaccurate and needs human in the loop to intervene and make an inference out of the recommendations made. So only when psychiatry moves from the symptom counting algorithms to context aware clinical reasoning systems, and also when our diagnostic systems change, we will be able to have a meaningful AI. And again, for misdiagnosis, so currently we always have human in the loop. Why? To take responsibility, right? So when AI makes a mistake, and if you sign, you are responsible. So just like, Tesla self-driving cars need you to be on the driving wheel. So even if it makes a mistake, you had to intervene. Why didn't you intervene? So this is something like that. So we are there to take the blame. Humans have to be in the loop. Then again, bias regarding training data. So again, there is huge dispute on whether copyrighted content was used, whether open information from the web was used to scrap, and how great is the training data, and all those issues do exist. Then again, every country has their own regulations, and with our own DPA, it is again difficult for us to take this casually or share the information with publicly available AI tools as clinicians. Then again, whose interest does it serve? For example, when AI is centralized, for example, there will be hardly 2 or 3 organizations left. For example, if when you see the big corporates are having their own apps, and they have like something called, for example, Apollo has something called clinical intelligence engine. So over time, what if they are able to, profile a large group of individuals, and what will happen to the clinicians? Will patients reach AI first or human first? So, do they offer, you know, uh, benefit to the patient per se, or do organizations stand to benefit? Like, so in the current capitalism, we don't know, like, who stands to benefit with the AI boom. So I'll discuss some of the work. So despite all these limitations, we have trained AI to do some basic additional assistant work. For example, we know two common tests used in psychiatry, right? Like psychological testing. That is, one is DAPT, draw a person test, and one is the thematic perception test. So the thing is, okay, DAPT, at least there are only two images, right? One male and one female image. Then you have to interpret, and you can make a reasonable interpretation. But TAT, there are so many cards, right? Family card, relationship card, like so many cards to ask the patient to write like complete one-page story. Then again, sit, interpret. It is very time-taking task. But because of the nature of TAT, like the responses are text responses, and they can be interpreted against, the conventional norms provided. So because it is possible to interpret just two images, and which are mostly lines and skeletons, and there is a very simple manual to interpret DAPT or HFDT and TAT manual, we have developed a model in which a patient can draw the DAPT responses, then again write the stories for all the TAT cards, and we can make a reasonable interpretation. So currently we are benchmarking against how psychologists would do, and over time maybe we'll use it as the first like assessment for patients coming. And again, one more, like for example, when you add additional investigations. So as I outlined in my previous presentation on improving objectivity in ADHD, so beyond clinical interviews, when you do continuous performance task, when you look at EEG, QEG signatures, and FNARS data, task-related FNARS data, it is very difficult for us to interpret, okay, in which second, during which activity, how was the oxygenation, and is there like fatigue throughout the course of the test. For example, conventional attention test, it's like just this many minutes, this many responses, and this is your score. So it doesn't give a great idea about where there is preserved attentional capacity, there is attentional fatigue, or there is like over time the person is not able to maintain the efficacy. So there are a lot of variables beyond what current tests can pick up. So by incorporating AI with timestamps, we can see like how the person started doing the test, what was there in between, so which kind of distractors do affect the patient. So by having more data points to observe, we are able to use AI enhanced assessment of the reporting. So what we do is we compile this QEG data, we combine the CPT data along with regular clinical evaluation data, and again additional clinical history regarding treatment response. All those things are fed into the system, and we get a reasonable response, which is better than what a regular clinical interview would yield. So that's why I mentioned it as AI enhanced, like we are improving the current clinical interview by enriching it with AI, which can interpret data better than what we can do. So this is particularly important for like, ADHD mimics. So for example, inattention is a common feature of like say anxiety, depression, bipolarity, simple sleep deprivation, substance use. Like, so it can be there in a lot of conditions, right? So to distinguish inattention from like the ADHD inattention, then again, we have this phenocopies, right? Like there are like autism phenocopies. They will look like autism, but it may be just, like for example, in level 1 autism, it may be just like, poor remission of depressive symptoms, which can mimic like less social interaction and all those things. But if you get a clear history, then again incorporate QEG data, you'll be able to see, okay, there is something more to it than what the phenocopy or the phenotypic presentation shows us. So like this is the the seminal paper most of be knowing about. Attention is what all you need. I just put it to highlight, this is just a notebook LM created illustration of the complete paper. So here I just wanted to point out one thing, right? Why does AI write a key SREY? It does so many good things, but why is it so stupid when it comes to spellings? Right? It can do a lot of things, but why is it bad with spellings? So you think about it. It can do a lot of things so well, but why is it bad with spellings? This also, like, right, the Legos are very popular after the Iran US Israel war. So when you add more sophisticated graphics in the background, for example, the mistakes are even more. For example, mania is written wrongly, bipolar is written as something else, depression, and like there are so many mistakes. So what happens to a AI tool when you add a layer of sophistication, like simple image in front of text? So with this, I would want to say that like AI has like a lot of potential, particularly in diagnosis, treatment, management. But the difficulties we encounter are the ethical concerns, biases in algorithms, and also the limitation in data sets. So what we should aim for is to have a safe, effective AI, which is in the best interest of the patient and not on the corporates or the makers. So currently, like, a lot of work is in progress. Basically, the same thing as I said, right? You can create a digital twin, and instead of running experiments on humans, the same AI model of a human being can be recreated. That is a digital twin who behaves like, or the model which behaves like the individual, and some testing or prediction of, like, treatment progress and all those things can be done. So these are the references. So just like, AI itself evolved from the work of, say, psychologists, then physicists, then the computer revolution just accelerated it. We stand on the shoulders of the giants, just like how our teachers, taught us. So with this, I would want to hand over the presentation to Dr. Iniyan. So he will continue with the terms, terminologies, and how we can understand AI better so that in the future we can incorporate that into our clinical practice. Sir, should we take questions now or can we take questions later?
End of the session, we can take questions.
Okay, sir. So I will stop sharing the screen.
Yeah. Then,
Okay, sir. Thank you, sir. I'll share my screen.
yeah, then I will go to the second speaker. I think so. He's
Good morning, all. Is my screen visible?
Yes, sir. Yes, sir.
Okay. Okay. Thank you for the introduction. I'm Dr. Iniyan, Professor of Psychiatry in Saveetha Medical College. And that was a very nice presentation on AI in psychiatry. So here we'll be focusing on the terms that we come across while using AI. So why should a psychiatrist learn about something like tokens, context window, terms like RAG, and words like models and everything? Because in upcoming months, and generally whenever you're reading a paper or any article, you will come across many terms like this. And so the objective of this session is that you by the end of this you will be learning about most of these terms and what they mean and what they don't. And second aspect is that it helps us to make informed decisions. See, for example, somebody is pitching you a new software and they are talking many terms. It may appear as jargon. So unless we know what they mean, we can evaluate whether what they are telling is true or plausible. And sometimes even papers also, when you are evaluating many papers, they may overclaim certain things. So the vocabulary that we learn today will be a defense against misinformation, and it will help us make many decisions. Even sometimes patients also they say they sometimes send the screenshots with chat GPT and all these things. We should know what are the possible mistakes that can happen. So, and another aspect is, see, whenever, even when we are pitched a new drug, which is, they say it is better against the existing drugs with respect to side effects or efficacy, we don't blindly start writing the drug. We start questioning regarding what are the papers, what is the how much is it better compared to a placebo? How much is it better compared to any existing drug? So we know whether RCTs have been run and what stage of like how many patients were involved. So we know the terms like RCT, placebo, to evaluate the about the drug, a new drug that comes. So something like that, we should know about these terms so that we can evaluate what the papers or the vendor, anybody is saying is true or not, and not to accept everything as at face value. So what we'll cover is the basics of AI. I think some of this were covered by Dr. Srinivas. We'll be this focus will be mainly on the terms. So we'll be learning about the foundations like what is artificial intelligence, machine learning, deep learning, and how an AI system learns. How is it taught? What it is supposed to know, and inside what is an LLM, large language model, and the about the latest in AI, the notebook LM, and just about everything. So, because the topic is mainly terminologies and some clinical safety terms. Okay. So these are the uh, foundations of AI. So artificial intelligence is something like a broader umbrella which covers everything that we will be discussing, or whatever that is come will be under the broader umbrella of AI. AI is something like a machine that performs tasks that look intelligent if a human did it. So yeah, something like a simple like a chess engine or even ChatGPT, everything comes under AI. Machine learning is a subset of AI. So, what is the difference between traditional programming, which you would have seen many, many years of programming, and machine learning? The difference is that traditional programming, you have to give an input and a set of rules, and it will produce an output. For example, you take PHQ 9, and you are giving a questionnaire, and you have to tell that okay, this is the form, and if you are giving the score more than 10, it is mark it as depression. Okay, so from this after that, any form that you give with PHQ score, the system will mark it as depression because you have set the input, you have given the rule, and it will produce output from this. This is traditional programming. But in machine learning, what happens is you don't give the rule. You give the input, you give a lot of examples, and then the machine learns the patterns, and then it forms the rules on its own from what it learns. For example, you give a lot of that. That's why a lot of data is important. You give like 10,000 PHQ forms with the just the score, PHQ score, and the diagnosis also. You are giving the diagnosis, but you are not giving the information that more than 10 is depression. So, but the machine learns this on its own, and then it forms from the pattern and it produces. So, next time, the after 10,000 you are training, if you just give the PHQ form from its own learning, it will produce the diagnosis. But you are not told it explicitly that more than 10 is depression. So, and deep learning is a subset of machine learning where it uses multiple layers, as Dr. Srinivas was telling about the artificial neural network. So, this aspect is used in most modern LLMs. Like this layer of what to say, I'll just give it just later on. So, the deep includes that there are multiple layers actually. So this is the AI family tree. So how everything comes about. This is like a Russian doll. If you see there is a Russian doll, you will have one doll. If you open and the other doll and another doll will be. So something like that. AI is the broad umbrella, and subset is machine learning. And even deeper you go, there is something called deep learning. And there are two types: generative as well as predictive. And finally, our large language models, whatever we are seeing, ChatGPT and everything comes under this. So all the LLMs are a subset of all this. A can do two things. You can like divide A into two. One is predictive and as well as generative. Predictive is you give it some data and it makes intelligent predictions. Like you give from electronic health records, it can predict from. You give vast amount of data, it makes predictions like who is at higher risk. For example, I think on a hospital in Hyderabad, they are doing like they have given a lot of data from their own electronic health records and everything. And the AA created a system where it gave a score like more than four, the likelihood of the patient getting admitted into ICU. So it based on lots of data, it predicts. So for whenever the next patient is getting admitted, it gives a score on its own. So this is prediction. And what is generation? Generative AI, it generates new output, new content, like it can be text in the form of discharge summaries, even any response from a chatbot is generative only. You get text from the chatbot. Of course there are multimodal AI which can also generate image, video, audio, and so forth. So this is two types. So this is something that you can see in news and articles also. Whatever we are currently like exposed to is called artificial narrow intelligence or narrow intelligence. So here, the AI performs a specific task, like a chatbot produces a text. Speech detection software does only a particular task. Even LLMs, so although they may have multimodal action, they are having specific tasks. So this is where we are today. Artificial general intelligence, you can maybe all the people involved, like Sam Altman, everybody, they may be talking about these terms actually, but still we have not breached this. Artificial general intelligence is like imagine somebody who is exactly like a human being, but with, of course, the vast amount of knowledge that is there. So they can apply the reasoning that I've learned everywhere into like so they can perform like a best physician at the same time as a best law expert, and they can produce art. All this a single AI, if it is able to do, it is artificial general intelligence. Still, it is hypothetical. We have not created it, but there is some discussions going on in this. And artificial super intelligence is science fiction. So it is like it will surpass all human cognition. So for an analogy will be like how we are to primates, to chimpanzees, that amount of how we think, how much the difference is on our thinking and primates. That will be the difference between our thinking when compared to ASI. So artificial super intelligence, it is still in science fiction. We don't know if they can be created or not, but you may come across these terms. So next is how an AI learns. Okay, you would have heard of ChatGPT, which was the pioneer, and later on Gemini and everything they started building. How did they make their AI learn to produce answers? So how did they do that? So one thing is called supervised learning, another is unsupervised learning, and reinforcement learning. So I'll give you an example. So supervised learning is just like, see, all these are machine learning only, but even in that there are some divisions. So one is like supervised learning is what we already discussed. You give thousands of PHQ forms with the diagnosis already marked, and from that it forms its own, that more than 10 is probably depression. So this is supervised learning. Supervision is in the form of because you are labeling, you are giving the labels. But imagine you are just giving a lot of therapy transcripts, or you are giving a lot of just health records without the diagnosis. You are just giving a lot of data, or you are just giving, say, you are just giving the PHQ forms without any diagnosis. So what it will do is you make the best out of it. You find something in this data. If you tell, the AI will try to form patterns and clusters. A group of, like, if you are giving 10,000 forms, it will, based on the similarities and scores, or it may be the pattern may be something we don't even know. See, we are not telling what to look for. So it may surprise us with many results. So a cluster may be forming, and we may see, yes, this looks like anxiety cluster, or this looks more like a depressive cluster from the data that we are giving, or this looks like a cluster which we don't know, doesn't fit into the existing diagnostic criteria. So this is where it is useful to find new patterns, especially as sir was telling about Srinivas, about the RDOC research, where it focuses on not an existing diagnosis. So same thing, the this type of learning makes the AAC clusters not with unlabeled data. Learning is reward based. So when the AI produces an output, it is labeled as good or bad. From that, it learns that yes, I should produce more of this type of data. This is also very important in how an AI is trained, because it does produce a lot of wrong data during the training process, and once we billions and billions of times it is told that okay, this is wrong, it's learning and it goes into a correct, streamlines into the correct path. So one of the things RLHF, reinforcement learning based on human feedback. This is an example which is seen in ChatGPT also. If you see ChatGPT, Gemini, it will ask you like which output is better, or how do you classify the output. There will be a thumb sign and a down sign. So you can say from that it learns, or sometimes Gemini gives two options. Choose the best response, like that. So from that it learns, and imagine doing this millions and millions of times, then it formulates its own path. So I think Dr. Srinivas went into deeper into this artificial neural network, so I will not go that deep. So simply, so this is the concept of deep learning, which all the LLMs, as you saw in the Russian doll model, all the LLMs are based on this, or a subset of actually the deep learning. So they are inspired by neurons, but what neuron here is, it is a node or a neuron. What we tell is a set of mathematical functions. So what happens is you give a set of data, and at every point of time there will be some like something called weightage. That data that you give will be a mathematical function, like it will be there will be something called multiplier. So it will be multiplied into something, and again there will be another data, another multiplier. So like this. So you give say a patient transcript or something. The patient, the at one point there will be like say suicidal ideas may be very important. So the multiplier may be more significant. But something like a loss of appetite, lesser multiplier. So this keeps, and the whole data will be again multiplied based on another set of rules. So this goes on, like imagine millions and billions of times. Or so these are the pathways, and finally it is adjusted so that you come to the correct output. So now coming into what is an LLM. So we call a large language model. Why it is called large? Large because it is trained on vast amounts of data. As Dr. Srinivas was saying, the ChatGPT and Gemini, everything seems to have been trained on the whole of internet. Whatever was available on the internet, they seem to have been trained. So the amount of data that was trained is large. There are something called small language models also, which are trained in very specific sets of data, like in based on company data, like that, which doesn't need all the data on the internet. So why it is called language models? Because see, whenever when we are dealing with LLMs, they appear to be giving the impression of intelligence or reasoning. Okay, so whenever you are asking any question, it answers actually, and we think that we presume that it thinks and answers. But what any LLM, ChatGPT, Gemini, whatever it is, what they do is it predicts the next most likely word. So it predicts the next most likely word in the sense that you give it any, for example, an example, this here, the patient with treatment resistant depression was started on. So you just leave it blank and type enter. It will go through whatever it has learned already. Lots of large data sets of data is there, And based on that, it will make a prediction of the next word being lithium and the next word being augmentation. So it just predicts. It doesn't actually think or reason. Even reasoning models, there are something called reasoning models. They don't actually reason. The only thing is this predicting the next word. They take some time. They have an internal that it will say thinking, where it is like actually keep on predicting the next word, but yeah, again, it comes to a conclusion. Finally, it produces output. What the difference between a normal model and thinking model is that the time it takes. It's like say somebody blurting out an answer immediately, and a seasoned clinician when asked a question, taking time to think and then answering. But still, the premise is they are just predictors. So that is why the answers that we get are probabilities. So they are not truth, or they are not actually from an intelligent being. So we should keep this in mind. So they are most like where they can be wrong also. So that is the concept of hallucinations, which I will discuss later. And a quick review about the LLMs that we will generally come across. So ChatGPT is an LLM by OpenAI, which was the pioneer, and by then Claude is another LLM. ChatGPT you can use it for basic day-to-day routine. Claude is more sophisticated in that it is very good for documentation purposes. You can use Claude for producing even this PPT. I think I made it with Claude. So Claude you can use it for making documents, PPTs, PDFs, Word documents, coding. If someone is into coding, they will know Claude is really good. But now late, I think Codex from ChatGPT is also really good. 5.5 version, they are telling for coding, even that is really good. And Gemini is the advantage is is quite multimodal in the sense it has models which are exclusively for image generation. So Gemini is really good for creating images. Or of course, reasoning, the so-called reasoning will be better with Gemini and Claude compared to ChatGPT. And the Llama is a local LLM in the sense that it can function in a local machine because it has lesser parameters, which I just say next. And the DeepSeek is from China. It is open, and actually why it revolutionizes. They said that it was produced in a very low cost actually. And MedPalm and BioGPT are medical domain LLMs. They are fine tuned based on biomedical data and models. So you could have heard something about Sonnet, Opus, ChatGPT 5.3 Instant, and Thinking Model. What are these? So models are like it's the same brand. It's like different parameter, different size, different capacity, different maybe use cases. So, for example, if you take Claude, it is HiQ will be the fastest and the cheapest. Like it doesn't use a lot of tokens, which we'll get to. Or Sonnet is something that you can use for day to day, and Opus is higher reasoning. It can use for say coding and other sophisticated functions. Similarly, with ChatGPT, instant thinking and Pro, and Gemini, you have Flash, which is faster, and Gemini Pro is more advanced. And but Nano Banana is a specific model in Gemini, which is only for image generation. So if you click Create Image, it starts using Nano Banana, that specific model. This is very important aspect of any LLM. So whenever they are talking about LLM, they will talk about these three things: tokens, context window, and parameters. So what token is like, it is instead of telling it can process this many number of words, that is from mathematical or as a computer perspective, there is something called token. A token is something like a three-fourth of an English word. So a word like schizophrenia has say three tokens approximately. And but other language tokens, for other languages, tokens will be more actually, 3 to 5 times more than English. So why this is important is many LLMs that generally ChatGPT, especially the free versions, after some time they say, okay, you have exhausted the limit. What's this limit? The limit is the token limit. So it will be like, say, after somebody uses like 10,000 tokens or maybe even more, there will be a break for 5 minutes or an hour. So every model has it actually, free version, even paid version also, even Claude has weekly token limits. So that is why we should know what is approximately a token. The second important thing to know here is something called context window. So context window is just like a working memory for an element. So how much tokens it can hold in its mind for some time. So why is this important is initially when ChatGPT 3.5 came, its context window was I think around 4,000 tokens. So that means it can hold in its memory only around 10 pages. So even when you're having a long conversation, after some time it will say you start a new conversation, so it will not hold, it cannot remember everything that was spoken in that conversation. But this is where as time evolved, the it exploded actually. So ChatGPT 3.5 was just 4,000 tokens. Now if you take Gemini, it is actually 2 million tokens. That means it can hold around 5,000 pages of text in its memory, in its context. So you can discuss about. So it does forget what you told about in 15 15 paragraphs back. So all this it can hold, and also you can upload more data like PDF with 100 pages. It still can hold everything in its memory. So this is the context window. This is quite important when dealing with LLMs. And the third, another important thing is called parameters. We were discussing about the artificial neural networks. So what parameters are like, as I told you, there will be multipliers at each level. So imagine layers are not one, two, three, four. There will be millions and millions of layers. So at each level, there will be many parameters. As Dr. Srinivas was showing the J, that I would like to take that analogy. Like to form that J, you have to adjust certain things. Like one thing you push this, and one thing you push this, like that. That forms the J. Something like that. So before the output, you these are like knobs you can push the different parameters. So if the more the knobs, more the parameters, the more sophisticated, the more excellent the output is generally. So, but at what cost? The cost is computer processing. So, Llama that I told you about, which is a local, it can run in your local machine because it has 8 billion parameters. Even that may appear high, but still 8 billion parameters. The processing power required to run can run in a local machine. But if you take GPT-4 and even other latest Gemini and everything, they have trillions of parameters. So there is a gross difference between a billion and a trillion in terms of how we see data. So trillions of parameters are there, and because of that, you cannot have. It requires. There are so many layers, and everywhere you have to have this computer processing done. So you cannot have run everything in a local machine. So that is where the concept of data center comes. Data centers are huge, like something like a computer farms. Like they have lots and lots of GPUs, graphic processing unit, which is used to run even games. So they have this GPUs, and there will be a lot of cooling system. It's like they take in a lot of area, like acres of lands, and have this. So that is the requirement for a system that has a lot of parameters like GPT-4 and everything. So they are more capable, more efficient, but still they are more costlier and a bit slower also. As Dr. Srinivas was telling, this is a very important paper that changed a lot of things when we are discussing about LLMs, large language models. Because if you see, everything exploded after this, after 2020. So 2017 was this paper. Then after this only, the all the LLMs exploded really. So that this is the transformer architecture in LLM. Okay, so for example, GPT, it means actually generative pre-trained transformer. So the T is the transformer. What's a transformer is, as I was telling, no, the every LLM predicts the next best word, next most likely word, by a lot of permutations and combinations by the what data it has learned. And but for producing that, actually, the transformer architecture makes it easier because it doesn't look at everything before producing the next word. For example, the patient who presented with mania last winter is now, if you just leave, it will say the most likely word is stable. Okay. But for looking at this, the attention, it doesn't go and look at every word. The who not, it just looks at patient, mania, now. So from just looking at these three, it can predict that the next word is stable. So this is the very important aspect because this makes it reduces a lot of cost in computational cost. And another aspect is a transformer architecture is like initially when like other things were created, the existing models they have to wait for one, like for example, one word is there, next word. So you cannot have the fifth word before the fourth word output is there. But transformer architecture is it does everything all at once. It is like saying instead of one doctor seeing one patient after the other, they have to see one patient, then next patient, next. So something like that. Instead of that, imagine 100 doctors seeing 100 patients all at once. So it reduces one patient takes 5 minutes. So it reduces the time cost by 100 times. So that would have taken 500 minutes. Here, 5 minutes, everything is over. So that is where the change really happened. And this also another point is it made scaling better. See, there is something called diminishing returns. If you talk about finance and everything, somebody is earning amount, you cannot apply the same on a larger scale. Somebody who is earning like 10 lakhs, his profit may be 30%. But if you keep on growing, the same you cannot get over a longer, higher amount of money. Or same thing if you say, if you just throw a lot of resources and money, everything doesn't mean any system will become more efficient. So this is the general principle, but this is where the transformer architecture was completely new in that the more amount of resources. So they thought, okay, a 10 billion parameter model should not be better than a 1 billion or more efficient, but it was. Then a 1 trillion model. So the more scaling that you do, actually it produces more better efficiency. So that's also very unique aspect of this transformer architecture. So this is the training pipeline. So if you are training an LL, somebody like ChatGPT, Gemini, this is what goes through. First, there is something called pre-training. So what they do is first they give it lot of data, as I said, the entire internet, and the model learns everything, the grammar, facts, reasoning patterns, everything, and then this is like somebody going to MBBS school. So and then the fine tuning comes. Fine tuning is like as the knobs, as I was telling, no, which is better, the which output is better. It is more like nuanced responses that is obtained from fine tuning the existing model. The model learns to be more helpful, just not a like a repository for data. So this is fine tuning, just like somebody specializes in a MD or any course. And as another important, as I was telling about RLHF, so it continues to have this human feedback, reinforcement learning with based on human feedback. Even now, ChatGPT, everything continues to have this. So here, if you see, like it is just like a clinical supervision of a student who has just completed MD. Still, we give feedback. The clinician, the professor or a faculty keeps on giving feedback, and the student learns from that. And finally, alignment. Alignment is even until the model is ready to be deployed, there should be some checks. So I'll mention that something called guardrails, ethics, and rules. It should not go against the law. It should not go against the. It should not harm the customer or the client. All these are placed finally. Despite learning all this, finally, and something like racism or all these things. At one point of time, I think Grok went all hail Hitler. It told he's the best person, something like that. So all these are done at a later stage called alignment. So and what is multimodal AI? Multimodal AI is a AI that can that can handle both input as well as output in not only a single modality like text, but image, video, audio, and all at once. So that is called as a multimodal AI. And we have, I'll discuss about Notebook LM. So notebook LM, why I want to mention specifically is like it is a place where we can explain many concepts. It is an LLM. It is a large language model only. It is powered by Gemini. Gemini is so it is free. So notebook LLM is free. Is if somebody has not tried this, I would suggest to definitely give it a go. It is especially people who want to learn a concept. If you want to learn a specific concept and you want to master it, you just upload the PDF and PDF, PPT, whatever, even YouTube link. From that, it generates like a timeline, it generates quiz, it generates flashcards, infographic, and it also generates a beautiful podcast, like 20 minutes. You can even set the time. How many minutes? There'll be two people discussing your concept of the topic. So it is an LLM and it is multimodal. As I told you, it accepts PDFs, it accepts audio, video, YouTube links, slides, everything, and it produces multimodal in the sense it produces text, image, video, audio. And we were discussing about context window, how much memory, a working memory an LLM can hold. It has 2 million. So that means you can upload 50 papers, 50 articles or papers at once. So it can hold everything in its memory and answer your question based on that. And this is one term, RAG, retrieval augmented generation. What is RAG is, so whenever an LLM is used, generally it produces data from the internet where it was, or it fetches from the internet, or where it was from the pre-trained data. But this something that has RAG has it gets data in and output only from the source you provide. So Notebook LM is an excellent example of that. So if you are uploading a PDF, it will give you answers based only on your PDF. It will not take from anywhere. So this is called as retrieval augmented generation. And so what it happens is generally many ChatGPT and other things, the common complaint is hallucination, where it gives completely false information. It gives fake citations and fake research articles. If you go and click, there won't be any actual article. So Notebook LM is good in that if you just upload a PDF or a PPT wherever, even it will have the function of citation. It will show you if suppose a quiz is made from that, it will show you where it got the question and the answer from the exact line from the text where from the PDF or wherever your source where it got the answer from. So it cites the exact source for every claim. So and now the future. What is going to come in the future? Like AI agents. AI agents are something like an LLM that does multiple functions sequentially. Like if you want to say set a patient appointment, so the one agent can what it can do is it will check your calendar, say next month when you are free, and again then it can call the patient, it can ask the patient when they are free to come, and it will fix a appointment date, and it will fix a appointment in your calendar, and also email or message the patient. So it can do so many things from a single LLM, multi-step actions in the real world. So this is the like the hot area now where everybody is creating agents, and it is like extreme. It can change the existing architecture. Even now, actually, many calls that we get from marketing calls are I think many AI agents are already doing it. So tool use or function calling is something like if an AI requires a specific function, for example, it requires access to a database or it requires a calendar. Suppose you ask for BMI. The model will not just guess. It will pull up the calculator function and then it will give you the exact. For you can see this even in Claude. It will if you say I want you to create a PPT or something, it will say, it will go to the Python library and download that specific function of creating a PPT or a document, or even it will say I'm creating a docx read file to read your document. So this is called tool use or function calling. And the latest, this is also a very important or hot topic called MCP, Model Context Protocol. So this is it's like a standard for letting an AI connect with your data securely, privately. For example, you have an electronic health record with lots and lots of data, and but you want it's not like something that can be just uploaded in a PDF. Then you can use Notebook LM, but it's like vast amount of maybe even live data, but I want to have Claude connect to this data. So how do we connect in a secure way, like a plug and play? This is where MCP comes. So model context protocol is where your data, a vast amount of data, connects through the to a large language model. So this is latest and another important thing that we can learn is clinical safety vocabulary. So hallucination, I think most of us may know, hallucination is a model, is when a model or LLM states something confidently, but which is completely false. Okay, so this is the most important risk that we face. Okay, it may be technically a hallucination that we can produce a completely wrong data. It can give a completely fictional, what to say, article link, or it may be contextual also. For example, today I was asking, like, I mean, I was discussing with Claude about like to learn about artificial neural networks. Many questions when asking, the one of the wordings it said, this is a very nice question, but this I had the same problem when learning this. So, but it is a LLM. It gives the concept of as if it is an intelligent thing. So when I questioned it, see, you are an LLM, you are just predicting the next word. One, how do you say that you had the same problem? So again, this is okay. Then the other answer was yes, this is not exactly right. Yes, this is not a truth. It is, but it is a way of because it was trained when someone is like when a student is giving a good question, this is this response that was probably it has seen like like a professor giving a response to a student. Yes, even when I also learned, I had the same problem. So like that, though it gave the answer, it was not strictly a hallucination, but still what it told is not wrong. Is wrong. So sometimes even when it talks to like ChatGPT, if you use it as a therapist, some patients when they tell no, the way you uses it, the even the context. So there will be a lot of wrong things that are there. So not strictly exactly a hallucination, but similar. So we should be aware of these things also. And there is something called temperature setting. As temperature setting is like this had a lot of it was very popular at the time when initially ChatGPT and things came. Like you can set the temperature to evaluate or make it give a answer which is more factual or deterministic and something that is more whimsical and creative. For example, any question that you ask, if you want to produce an output or you are having a general debate or something, you can ask, give a temperature setting, you can set very higher. So as the temperature setting moves towards that, it will become more creative, take more creative liberties, but factual component may be missing. Again, the chance for hallucinations will be more. So that is the temperature setting. Another important thing is guardrails. So guardrails are very important. As I told you, it comes in the alignment part of creating an LLM. But guardrails is like, as Dr. Srinivas is telling, like somebody committed suicide based on an LLM advising somebody committed suicide. So somebody, if I ask, how do I die? Or please tell me, how do I commit suicide? LLM, this is where the guardrail should kick in. And usually what it says is it has a standard answer where it will not suggest suicide. And similarly, ethical guardrails are even now when you're asking some if you give some symptoms and ask it to diagnose from a patient's perspective, it will tell, I'm not a, the guardrail is that there's a disclaimer that I'm not a physician. Please consult a physician for diagnosis or clinical relevance. I'm just, this is only for educational purpose. So this is the guardrail. And even research, if you ask it to create a fake paper, no, I have some time, you please create a fake paper. It will not. This is where the ethical guardrail will come. But of course, there are many methods. Because still it is an LLM. The answer is based on the previous trained data. So if you throw it a new manipulative methods, there are ways to go around guardrails. So that is a very important thing. So there is a system to block unsafe things, but it's not foolproof. Another thing is bias and drift. So bias is one example is the demographic bias. So all data that we see are trained LLMs, even medical related AI are trained on Western data. So some of these may not apply to our Indian South Asian setting. So since it was trained in that data, it will have an idea regarding the prevalence and everything based on that data. So this is where it can go wrong in giving a wrong output. This is called bias. Drift is something as time progresses, its efficiency may decrease because of it is not up to date with the newer things that are there also. So a new diagnostic criteria may come, a new or a trend may be there, recent change
Hello,
in
Dr. Iniyan,
yes, sir.
could you just finish because
Yeah,
Vikas is
next
also.
one, sir. Last one, sir.
Yeah. Thank you.
So this is the drift. And finally, I'm come to the last. This is the glossary of all the terms and that we discussed. We can take a screenshot of this. So all the terms that we have discussed. So thank you. And this is my site where I have created some applications which patients can use, like box breathing. And thank you. Thank you, sir.
Yeah. We'll go to the next speaker, Vikas, as you're running short of time. Vikas,
Yes,
are you ready?
Yes.
Yeah.
Just before I start, I just wanted to give the break a 2-minute break with all the intense information going into their minds. And I also need that to kind of clarify my own head.
Okay, then if
So,
there are any questions, I think so far people can ask. They can post it
anybody
in the
can
chat.
unmute and ask question.
Post it in the chat, or they can unmute and ask.
This is Dr. Rajkumar. I am pretty old in this. I've been trying to follow artificial intelligence psychiatry for the past 40 years, starting from the state of present status examination to current thing. Even before that, Alan Turing's test of what is thinking in a mission, kind of a thing. From that, we have come past a long way, and most of the things that are talked by Iniyan and Srinivas are quite new to me and really enlightening. But the field is too vast and broad for me to grasp. Maybe that's my fault, but may I request both the presenters to sort of give a write-up and elaborating a bit more, and then maybe putting it in some group so that we can access it and read it so that it will be informative for us. That's just a suggestion. Thank you.
Sure, sir. Definitely, sir. I will create a write-up regarding this.
Yes, sir.
Thank you so
Definitely
much,
we'll be doing
Rajkumar,
that.
sir. I
Thank you
think
for
that
the
was a
suggestions.
very valid suggestion. So I'm just sharing my screen, and I think we can get started. So I think that was a whirlwind. Lot of terms, lot of technologies discussed, lots of names, and I think I'm going to make it much more simpler. Uh, for me, when I remember when I got access to the internet, I knew that there was something called the internet. This is before we had a computer at home, I asked my father to buy me a book. And this book essentially had a list of websites that you can visit for when we bought a computer and when we got the internet. And from that point on, wherein accessing information was so exciting and something that you look forward to today, where accessing information and technology is instant, we've indeed come a long way. Uh, Coming to the topic I'd speak about, I think people who are used to using statistical software from before know that there needs to be a certain logical input in order for us to have some sort of logical output. And with advancements in tech, this applies today. So garbage in, garbage out applies to using uh, our day-to-day AI tools as well. I have to say this whole presentation was created within a few minutes, including the animations, with the help of Gemini. The content was a little bit of mine and a little bit of AI. So this is one of the major use cases for us to start with. So as we look at the different things that Dr. Iniyan and Dr. Srinivas spoke about in terms of the uses of AI in psychiatry, I think we should leave the word psychiatry out. AI is technology that we as humans use to make our lives easier so that we spend lesser time doing psychiatry and more time doing the things that this planet offers. But currently, if I wanted to read an article, write an article, conduct research, make some psychoeducation post, write a referral letter, brainstorm about a patient, uh, read a book, all of these are extensively time consuming activities. Not saying these are not things that people would want to experience, but I'd like to do it a little more quickly. So I think for us as individual psychiatrists, rather than people who are making diagnostic systems and improving the science as a whole, I think we can use psychiatry to save time, do our tasks a little quicker and easier, and move on and go spend time with the families that we really care for. Now, when we're going back to the industrial age, when we first started making machines, machines that were cooperated with valves and screws and pistons, communicating with the machine was very difficult. For example, if I want a car to go fast, I need to press, it has to pull something, something has to get sprayed, something has to blow up, and then it goes fast. And as we moved slowly away from mechanical machines, which mechanical computers also existed, to code somewhere in the 70s, 80s. Now, a bunch of really intelligent people thought that it was a good idea to come up with some sort of complex language to do simple equation. For example, for older coding methods, to generate a simple statistical output would require you around 2 weeks of training. But as time has improved, especially with uh, computers being able to understand English language better, and more recently in the last 3 years, a lot of complex computational activities can just be done with the use of prompting. Prompting is essentially using natural language to instruct an AI. Now, I think I've said meet the staff because at the end of the day, these guys are working for us. Uh, and I think Dr. Iniyan already gave us a good overview of what tools exist. I personally use Gemini because for low cost, it gives you cloud storage plus pro membership. The free versions are terrible. The paid versions are better. Anybody who's used them would attest to that. Grok is something you use if you want to have a good time. It used to be good at coding, but right now I don't think it's good at anything except coming up with really blunt and rude responses. So if you like coding, stick with Claude. If you like anything else, stick with Gemini. I think like Dr. Iniyan said, Codex from ChatGPT is good as well. Now coming even before we proceed in terms of what kind of inputs generate useful outputs, I think we should all remember that irrespective of what the circumstances, never, ever, ever enter patient data or identifiable data into anything on the internet that isn't local or that doesn't have a guardrail. So none of the models I mentioned should be used to process identifiable data. This does not mean I don't process patient data, only that patient data cannot be identified, and irrespective of how many guardrails exist, you are the final guardrail. Even when ChatGPT came up, I think 2, 3 years back, and I think we all remember the time where you had to wait. You could have a few conversations and then you had to wait like several hours or days before you can continue. We started treating it like a friend. We started believing that it knows more than we do. A good example of how casual prompting works is I think when I was in postgrad in Ramachandra, it was a very busy day, and I essentially asked one of the interns to write a discharge summary for me. And this is what I exactly told her. Hey, I know you're new here, but look at a few other discharge summaries and write one. I don't have the time for it. And she did. She was obedient, but she didn't ask me any questions. And essentially, the next day, the patient came back with nothing on the discharge summary except a physical examination and some medical diagnosis. Uh, Thankfully, we could just push it off into some sort of printing error, and we could fix that. But AI is like that. It is extremely knowledgeable, interested, but unless we instruct it properly and supervise the instructions, it's going to give us random stuff which may not really be useful. So, coming down to what I can use it for, I'm only using personal use cases. As many of you may know, I've closed down my practice and I moved away from that. And as part of that, I had to write hundreds of referral letters. And again, it's a process, right? So, in the beginning, when I started writing, I assumed that the AI or LLM I was working with was talented. It could do better, which I thought because of the language it used. But once you start giving it incomplete information, it kind of comes up with really nice letters, but essentially not very useful. So over time, we learned that uh, the way you structure your input determines the quality of the output. Now, psychiatry is not really disconnected from how AI works. A big premise of the simplest idea with which any kind of intelligence works underneath is the relational frame theory, wherein our brain uses an existing pool of knowledge to inculcate new bits of knowledge. So I think ever since I heard the term prompt engineering, which seemed like a very complex, high level task like learning a new coding language, I've been looking at it. But it feels quite simple to do, at least for us, for our day to day use cases. So, in the early GPT models, we had to tell the AI what we wanted. For example, let's say I had to give it an example of, hey, patient slept well is a good thing, patient sleeping, not weeping is a bad thing, and then give it what I wanted to process, and that it would process it. But as it got better, as models got better at understanding language, especially because so many people started using it and machines could understand human language a little better, uh, we could move on to chain on thought. So, which means if there is a complex clinical problem or complex bits of information that I wanted to obtain, I start with asking one question first. Hey, what is the duration of illness? Two, what are the symptoms? Three, what is the severity? What are the medications I've tried? So chain of thought prompts work well because they simplify the task for the AI and they still work well today. Over time, we have to remember that LLMs are primarily used for coding, and if you recognize that's what they're getting way better at with time, everything else is kind of a side hobby for them. In the last few years, you might have come across YouTube videos, Instagram videos, even attended courses or gurus talking about specific ways to prompt. The RTF and the clear format of prompting are kind of similar. In the RTF, R stands for role, T for task, and F for format, where you start with act as copywriter, psychiatrist, pharmacist, statistician. Task, process this data. 3, give me output in this specific format. Uh, Clear is a slightly expanded version of it, wherein we provide context in terms of what is happening around the situation. Here, this person has been tried on risperidone, clozapine, pimavanserin, but he still is hallucinating. We also provide lab tests if we have them, investigations if we have them. We can also upload MRI scans and EEG scans and QEEG reports. That's the context. We don't want some random info, so say limit your response to 300 words. We give them an expectation in terms of what kind of outcome I want and what kind of action I want the AI to provide. And I also feel like the last refine is a good question or to put in to say, ask me a few more questions if you're unclear about what the task is or to clarify the task. These are essentially very simple structures that can make my results a little more predictable. Coming down to doctors, I think we can create our own structure of prompting, which can mirror RTF or clear, but which is something that's a little more similar to our jargon. So we use the SOAP to make progress notes all the time. So if we can start with a situation, which means, like in the example, set context so that the AI understands what is the context I'm talking about, provide the context first. Then objective, what is the objective I want? 3 is the audience or actor. Am I going to write this to a patient? Am I going to write this to a doctor? Am I going to write this to myself? And finally, parameters. In parameters, what is the exact format I want? What are the guardrails I want to follow to prevent or be open about hallucinations? For example, in a situation, let's say I'm a consultant working in acute adult inpatient unit, I want to write a handover note to my primary care GP. The objective is to draft a clear stepwise transition plan. The actor, the academic, clinical, and the parameters use bullet points max 250 words. Now, this is an example. So what I use personally in all the AI models I use, and sometimes you can do this via the settings and apply it to every chat, every conversation you have, or add on a prompt, add on a line in the parameters section that says, provide a confidence score for the information you're providing, explain specifically why it's not 100%, and add your list of medical references. Now we have a very simple structure, right? We have an S, O, A, and a P that can guide our prompting, which can give us a little more relevant results. Now we're just going to come up with a few examples of how we use it. This is exactly how my notes look. In fact, my notes don't even have plan, risk, and all, just a bunch of words. And let's say I want to share this with the therapist this person is seeing, or with the patient themselves. I can quickly convert it into a readable, more understandable format. Now, this is also something that we use AI for, that we read, we learn from it. So here again, if you look at this prompt and read it for a second, you would see our SOAP parameter working very well and giving an output that's kind of useful. This I use for psychotherapy appointments and referrals, especially if I'm writing letters for patients where I don't want to use any words. Now, a lot of people might argue using this is going to get rid of your ability to use the English language, which I kind of agree with, because I feel like I've lost my ability to spell words because the AI can fix all the spellings. But I also feel like this saves a bunch of time. As someone who's written around 500 referral letters in the last 6 months, I know how much time it's saved and how much time it's given me to spend my life a little better. A common practice for me is if when I notice a session hasn't really gone well or I haven't been able to communicate something to the patient, I always follow up with an email. Pre-AI era, it would take me 15-20 minutes to figure out the right tone, right message, right language to send to the person. Now it takes me 5 seconds. This is something that's been useful as well. Now, we've been talking about hallucinations. Before hallucinations, I'd like to talk about something called context degradation. So, when you are prompting an LLM to give you an output, the accuracy of that output kind of gets worse and worse and worse and worse as that conversation goes along, as long as it's not a repetitive activity. For example, with referral letters, if I chose to write all my referral letters in one conversational thread, it often gets mixed up and hallucinates a lot. So we've come up with a very simple prompting format. And I think if we can remember context degradation, which means if I keep prompting the same conversation over and over again, the chances of hallucinations improve. And I don't really have to tell anybody that we're not going to use AI for final diagnostic decisions or acute crisis management. So what can we do with prompts and LLM? Anything actually, limited only by our creativity and the time you have. So with that, that's a whirlwind end to my presentation, considering that the previous presentations were quite deep. But I'm sure all of you got invited to this uh, meet via WhatsApp, right? So I'm going to give everybody some homework. You can use any AI tool that you want. Uh, so 4 bits, and anytime you do this, you can post it in the group, because I think the main idea of this presentation was not theoretical. It was to understand the theory and leave with a skill that we're going to practice. And we are going to get a little deeper and deeper with these sessions, wherein the next sessions will be about using tools or using it for statistics. And we hope to get to a place where everybody is really comfortable is using AI for anything that they want to do. So 4 bits of homework. You can look at this if you want to do something different, but it'd be nice if everybody who attended posted at least 4 bits of things that they did with AI post the session. Before we end, I can see a lot of ticks on the screen by Dr. Prabhu. I don't know what that is, but we'll finish with a simple quiz. I'd like people to use the chat box, though I can't see the chat box, to come up with an answer. Currently, what do you think is the purpose of AI in a clinical workflow? Let's say automating friction. For now, that's that. What's the golden rule of AI prompting? I think all of us know that it's no patient health information. Uh, what does P stand for? Is parameters, where we also include the guardrail. What guardrail helps a little bit, provide a confidence score. This is not 100%, but it's better than nothing. And over the years, I understand people have become less and less skeptical of AI, considering, like Rajkumar sir said, this all seems a little new and complex to us, but in reality, it's not. It's simpler than the things that you guys did. It's simpler than sitting with a piece of paper and a complex statistical equation and coming up with a paper and writing the whole thing without spell check. This is way simpler. And I think, like Rajkumar said, sir said, the biggest idea is to make this simpler for people to use it a little more. We are not building LLMs, we are using LLMs. With that said, we need to question the outputs, we need to demand evidence, but not avoid using tools that can make our lives so much more simpler. So with that, I end my presentation and thank you for your attention on this Sunday morning for the last 2 hours. Thank you so much, and we can move to questions.
Yeah, thank you. I think so. Almost nearing 2 hours, It was a very good presentation by Dr. Srinivas, Dr. Iniyan, and Dr. Vikas. I think so. If, now the session is open for questions, and we can move on with if anybody has any of these questions. A question from Prabhav. Any of you all want to take it? Vikas,
I can take it. Yes.
Yeah.
I think yes, it can. Uh, if we can give a proper history, diagnosis, lab tests, QEG, MRI, all of it can come up with a nice diagnostic formulation. But I think diagnostic formulations are not limited by AI currently, but are limited by clinician knowledge. Uh, because it might come up with a formulation that we don't understand because our field is so deep. But definitely it can.
Dr. Suresh, sir, have any questions?
I don't have any questions as such, but I really, like very happy that I was here this morning listening to Srinivas, Dr. Iniyan, and Vikas. So brilliant presentations. I think we really have to appreciate that young people have presented so much information, all new knowledge for many of us. I'll agree with Rajkumar that you're all completely, like novice to the idea of, artificial intelligence. And I guess, like we learned a lot today. My simplest thing is we can't escape AI now. And I think we really have to integrate seamlessly AI into our real world practice. So I have two important observations to make, and I maybe a comment, and I think any of them can answer. So we are going to be integrating AI into clinical practice very soon. And I think there the only concern we have is what Srinivas raised is the ethical concerns. I think if you are clear about, I think there is a conference that is coming up in next month, first week. I think IAPP is organizing a CME purely on ethics, empathy, and artificial intelligence. It's pretty timely because I think we are exploring how ethics and empathy will, like intersect with artificial intelligence. So that's something that we need to be thinking very seriously about the ethical concerns in real world clinical practice. For example, like I hear a lot of young people when they get a report, for example, of an EEG or of a QEEG of anything, like then upload it directly into the, chat GPT or Gemini and ask for interpretation rather than relying upon the specialist. And how far this is going to be, like ethical, because, I think, I don't know how you remove those identifier information from those things, like I think there's something that we need to be very careful about. And I think what are the implications of it, ethical and legal implications of it, I don't know at this point in time. If somebody can illustrate that, be good. Second, I think I don't think there's any legal issues, I'd say, but I think ethical issues are more important in this particular one, uploading and then trying to interpret. And also, I was actually wondering, who write publications, I think while we take all this into consideration while writing paper, many of the journals are asking upfront, have you used artificial intelligence? In what you use artificial intelligence? Even if I go as a reviewer, for many of these reputed journals, they ask a simple question: have you used AI in reviewing this particular article? In what context? So I don't know how journals are going to look at as a. Some journals are very positive about incorporating AI into their like review process as well as in the writing process. Some may be very skeptical about it. So also we have to be very clear about it. I don't know whether Vikas and Srinivas and Iniyan had any comments on this. Thank you. But brilliant presentations. I think the morning was very, very productive. Thank you.
Dr. Vidya?
Yes, sir. Thank you so much. This is Dr. Vidya from Madurai. This is a wonderful session, and I thank TNIPS committee to organize this webinar. And the three speakers gave a wonderful inputs regarding this AI, because as like many of us think, okay, AI is threatening a new way to learn and all, but actually it is interesting. It is like learning a new language, updating yourself. Like as our medical field updates, even the technology updates. When we learn a new language, we have to know the alphabets, the basics, and then we can upgrade ourselves based on the knowledge. Similarly, you have given the alphabets and basics of AI within 2 hours of presentation. That is wonderful. And there are few feedbacks that I want to share based on my experiences and also based on this presentation. So what I what all of us have faced is we have to know about AI not only for our knowledge, not only for but also for a clinical practice, because every other day we see clients who are using AI for their complaints and then come to us. So unless we are expert in that, we cannot handle those patients. Second, though the term like everywhere AI is being used, it is not so frightening as it is. Once we know about it, we can easily manipulate it according to our wish. So it is just a technology. It is not like it is a skill to develop. It is not a threatening or a new thing to be afraid of. So that is one input. And second is AI and digital technology is always manipulative. They are not creative. As it was beautifully said, it takes information, learns from its experiences, and gives us productive things. But it is not superpower than our mind. So you can learn it, manipulate, you can use it to upgrade ourselves, though sometimes it makes us lazy. If you are used to AI technology, using it, it makes us little lazy. You cannot sit and write case sheets now, especially like younger generation like us. If we give a paper to write, we are little hesitant. Instead, we'll just type it off and very comfortable with digital media. On the other hand, it reduces a lot of time, and if we use the remaining time productively, it is very easy, as we use transport to save time. So these are my feedbacks, and thank you so much. This Sunday was really productive, and we are waiting to know more about this in future sessions also. And definitely we'll do the project, Dr. Vikas. Thank you so much.
Thank you. Dr. Iniyan and Dr. Vikas, you want to say something about Dr. Suresh has said about ethics and about the legal aspects briefly.
Regarding the research, sir, yes, as sir was telling, many journals ask upfront. I think if he had used AI as some part of, well, for formatting or for summarizing, so we can mention that as in the article itself, or we can give a clarification. But if you are just using it for spell check or any other aspects, because then that need not be mentioned. But of course, we should mention that all the other analysis, the data collection, everything was their author's own efforts. So the scientific content, everything. So we can make a distinction, and it's. I think we can be upcoming. If you have used AI somewhere, we can mention that.
I think some of the journals, like the authors themselves, use AI, because I have got AI inputs from authors of some journals, like editors of some journals. Then again, they use an interesting terminology called AI was used for linguistic proofing. It's not like AI was used for writing. So people try to, mask AI usage under different terminologies. But I think it is only a matter of time before like AI screens the articles in the initial stage and then sends to us for review. So I
It's
think
already happening in many journals. I think the first review is done by AI straight away. I think they only, so the screening is done by AI. Otherwise, the efficiency, because the reviewers are not there these days. They are unpaid reviewers, so they don't get it so easily. I think the screening process is done. But I'm just worried how much can we do it for journals who are not accepting that. I think we have to be very careful in writing that. Thank you so much for that. Okay.
Actually, a lot of articles are asking for disclaimers to use AI. So to bypass the disclaimers, they are using, as Sir told, a lot of terminologies, like AI was used only to realign the paper, to just proofreading, for linguistic grammatical checkup. So which
then
needs to be clarified.
For creating illustrations, and that is all permitted actually. Like some of them we can use So people
Especially for
have even
psychotherapy
in
papers. For psychotherapy papers, they are using AI disclaimers.
yeah. Then again, regarding like even in conventional tools, as Srishmar sir was pointing out regarding like, can an individual share like the data to the AI? There are some options, not to retain the information. But as Dr. Vikas also pointed out, we cannot trust them because anyway they have to process this with their knowledge base. So we never know, like because when I proposed my project also, I claimed that okay, it is like mixie. We are using electrical energy to propel the rotor in the mixie and it is going to grind. There is no way this information will go to the other side. So it's easier to say, but even if we have a custom GPT, there is a possibility that the information which we interact with AI in the container may be used. But the best way to protect data is to have a local LLM, as Dr. Iniyan also pointed out in the slide, to have a LLM on your own system or on the cloud, which is not connected to the network. So that is a better way to safeguard data, but individuals should be careful. But ChatGPT now has a separate option, ChatGPT Health, that they encourage you to upload your own data, and it will be providing periodic inputs about what you should do. I think they are trying to monetize this over time, that because you have these conditions, this is time for your checkup. So I think their intentions are commercial. I think both the clinicians, then individuals themselves should look for some, protective frameworks, how to safeguard, people from being taken over. It's like having a personal clinician, Mary. They may try to push that way. Just like coding is replaced by, just tools rather than having individuals. They are trying to replace this layer of, like, for example, GP consultations may be taken over by AI, because if you want a report to be interpreted, you have to wait, get an appointment, go and discuss the report. But now you can snap a photo, upload, and ask for feedback. So I think we have to look for it. And even for screening, it's not only about screening articles. Apollo screens patients using something called clinical intelligence engine. So when somebody books an online appointment, by the time you get an appointment, the patient would have like given input of all the information history, would have uploaded his prescription, and by the time he comes, it would even suggest possible diagnosis. So corporations are starting to use AI in their routine clinical data capture, and we don't know, like, just like, see, there is huge criticism regarding how Practo handles data, HealthPlix handles data. So Practo, if they see a dermatologist, so before the prescription is going to be over, and if they sense that it is a continuous recurring prescription, what they would suggest is, we will give you the same medicine at 20% off. So doctors are seeing that, like, for the next time, the patient doesn't come to you to get the medicines. He wants to buy from a Practo affiliate. So there are a lot of issues in incorporating AI into, say, healthcare. But we should be careful about, recommendations and also using.
Thank you. Thank you. Extremely useful. Thank you.
And I think we should remember that AI is here to make our lives easier. Yes, there are ethical problems. Yes, people may not know how to anonymize data. But if you remember the early Wild West days of the internet, sir, where it was just there, everything, anybody could do anything, and viruses were everywhere. I think that's the phase we are in with AI. As companies get better at monetizing their services, you'll recognize everybody will have to pay for a simple conversation with ChatGPT also. And I think when that happens, things are going to become a little more streamlined. And with the articles and research papers, I think the primary point of a research paper is to transmit some knowledge and information. Now, whether that is written by my own effort or by technology, as long as that outcome is reached in the quickest, safest, most reliable manner, I don't think journalists will mind. And I think all of them are moving towards, I don't care how you got it, but this needs to be good science. And I think that's the core of research. This needs to be good science. I don't really care how you did it, but it needs to be, it follows the rules of it being good science. I think that's where we will get to. That seems to be the most effective way to do it rather than depending on formats. For example, for now, for me to read an article is boring for me. I need to read it for 2 hours. in order to understand what this person is saying. And there's a lot of redundant text in the formatting of articles. I think all of that will change where you're able to gain information quickly. I'm not saying the useful bits need to go, but there are a lot of useless bits also in research articles these days. When they go, and I think AI will form a big part of that, life will become much simpler for those of us who don't really enjoy reading large chunks of text. Thank you, sir, for that wonderful question and lead on to the discussion.
Thank you, Vikas. Nice seeing you.
Okay.
Thanks,
Any
sir.
other
I had a
questions?
question, sir.
Yeah.
How would we be able to use AI in predictive psychiatry, sir?
Can you expand on your question?
Like if I wanted to, so I was reading up on this topic and I have seen that when I was inputting this on AI and asking it to make something out of it, it was telling me that most of the times when we are starting treatment for patients, we do end up facing a little difficulty in choosing the right antidepressant or antipsychotic, and the patient does not respond that well to the medication. And if this information was given a little more accurately to AI would predict it better. But then I wasn't able to understand how would AI do that. So is it possible, like predictive psychiatry is there, or it is not going to be useful for us? Is what I was thinking on.
That is
And in any other
Dr.
areas as well,
Srinivas'
apart from the
question.
treatment aspect.
See, if you
Sure, Dr.
ask,
Srinivas will give you examples of how he's done this also.
yeah, see, for example, like predictive psychiatry is what you're also doing in clinical practice, right? So, based on the clinical symptoms, even depression, if you see like the patient is having agitated depression, you choose. So, you are also predicting the treatment response based on clinical features, right? But now, when you have further variables, for example, you have QEG, right? You have QEG data which is not like showing the typical picture. For example, in ADHD there is no increased theta beta ratio. That is a predictor of poor response to methylphenidate, right? Then in CPT you are seeing like, you know, excess of attentional fatigue and all those things, but preserved capacity in the initial time. Then you would think, okay, this is not ADHD, the person is having inattention, poor performance on continuous performance task. But if you look into the details, you think, okay, this may be, you know, residual symptoms of depression which have not cured. So by incorporating more and more variables, say from multiple things, multiple sources, clinical history, then for example, you do a scale, right? For example, if you do SRS or WORS, what do you see? Like you see the composite score. Okay, by the time you go to treatment planning, you don't remember, you know, where did the patient score. But now if you enter into AI, it will know, okay, it will warn you that, okay, these symptoms were present, but you are prescribing this medicine. So do you want to reconsider? So beyond the number of variables which human mind is capable of holding, a machine can hold. The same thing like using a calculator, right? So okay, you can do calculation, but will you resort to calculation? So over time, as Dr. Vikas says, you know, do you want to use machine so that you can do things which have more meaning to you than, you know, getting caught in the nitty-gritties or in reading the fine print or reading twice to understand the, you know, subtle sarcasm of that. Like so, it's about, you know, like maximizing life, the finite life we have with the infinite capability of machines. So I would say, um see, QEG prediction is not like for now, right? Even QEG, if you start reading a paper, by the end of reading the paper, you would not know, okay, what is like recovery, then what is power, what is synchrony, and all those things. By the time you are done, you cannot hold all the variables in your mind to analyze a QEG as a human being and make a recommendation, but machines can do. Then regarding loss of essential skills, you know, people say like, yeah, it's like Ferrari of the mind. But would you not learn driving a manual car? Like I think more than 50% of people in US don't know how to drive a manual car. So it all depends on the, like, you know, need of the like day or time we live in. What is essential, what is inessential. By that way, if we see human being are at their most fragile self, right? Like physically, for example, early human beings, some 50 years back, everybody would be able to run a marathon, but what percentage of us would be able to run a marathon? So it depends on changing times. We have to reorganize ourselves, and particularly practice of psychiatry, which requires so much of human effort. If we are able to, like for me, if you say, if we can put our thoughts towards that can reach more people at the shortest possible time, even if there are inaccuracies, I'm okay using that. The same way I pointed out in the slide, right? There are mistakes, like key is written as REY. That is because how AI works. But a reasonable person, even patient, like may be able to, let go of these inaccuracies, just like we humans also have, and look beyond that and understand the gist of the information. So I think definitely like it can do things beyond what man can do. You can think like it's like Steve Jobs said, no, like AI is like computer is like bicycle for the mind. Like okay, you can travel inefficiently by walking or jogging, but when you have bicycle, yeah, so it only enhances us. And Dr. Vikas, I like either Doctor who asked the question. So I don't know exactly what he wanted by predictive psychiatry,
Oh,
but
that's wonderfully answered, sir. Thank you. This is Dr. Rahul Khemani. I'm from Mumbai,
yeah,
actually.
yeah. So nice to listen to your question, but definitely you can incorporate into your practice and make sense of information. The same thing with clinical history. See, right? Like after 10 medicines, can you hold in your medicines to what medicine the patient responded in the first episode, second episode, what side effects did he have? But when you input into the trained AI model, you can make sense of that. So whenever possible, treatment history, I ask my students to type so that you can, put it and see, okay, what worked better, what didn't work, what was the dose range, then what. So it's like having an additional layer. It's like having, a extra arm or an extra assistant to work with. It's like having a second brain.
Yeah, I think so. We had wonderful discussions also, and I think so. We have crossed almost 120. So, Dr. Prabhu has put a lot of questions on the post about using the tools. Questions are related, creating e-posters and animations and things like that. I think so. We plan to have subsequent sessions focusing on Notebook, LLM, and other tools in detail. So probably we can have a discussion in the subsequent sessions, either online or offline. That we will inform the group later, the dates and the topics, and so that can be covered. And and Dr. Rajkumar is there. He wants to add any. Sir, Dr. Rajkumar is there? No. Okay.
Just Dr. Sadanan, just for the
Yes,
group's
sir.
information, ANSIPS Madurai has a
Yeah.
scientific team of transformative technology and therapeutics. And I'm really happy to know that there are several experts in this group who can actually be there showcasing their talents in this. The whole conference is around the theme of transformative technology and therapeutics. No better way to kickstart it like the way I listened this morning. Thank you. Thank you for organizing
So
this.
yes, sir. But the idea was this was started was I didn't want to overlap the theme of ANSIPS, but the idea was many people started reading even in some of the ANSIPS. You have topics related to this. A few topics on that in the past ANSIPS and zonal conferences. So many times it'll look Greek and Latin the words they use. So I said, why not we start off with the basics and probably progress on usage of tools. And because other specialties, I see many people are actively using AI agents and the short tools for screening, which I think so we are lagging behind. And I thought our specialty should be moving to the next step. And I thought, why not we make a beginning on that? And that is where we started this. Probably in my last 2 months of term, I'm bringing it. But anyway, I thought let's do it. That is where
This is
this.
relevant and like very, very timely. Thank you.
Right, sir. And thank you all for joining the session. And till the end, it's almost 1:20. And thank you all. We'll keep you updated of the next session, which we have probably next month, either offline or online. That we'll decide and let you know. Thank you all. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.